To extend with more technique of using the new added column, I want to show you something about more with the functions and the variables you might can use in the lab. So let me give just a random name. Just say calculate. Column. So there are some if you try to use Fourier transform, then you can go to if you want to go use bandpass filter, here's a function called digital filtering. You can use low pass filter, high pass filter, band pass filter, band stop filter, and time decay filters. And I'll take band pass filter as an example. So this is the function name or the function handle, and then inside the bracket you will having some variables you need to carry out the calculations. But for now I have no idea what are those for and what's the order of them. This is where the help is really going to help you. So you click help here, and it will shows you the help information for this defending new calculate column. And if you scroll it down to the functions, you will see those function handles, function names here, and then how to use them, what are the variables inside the bracket needed. So as examples here, we're using the bandpass filters, so we're going to find bandpass filters the inside of digital filtering. So digital filtering, bandpass filter, that's the 4 variables that we needed. So y, x, lower frequency, high frequency. Y means the data, x means time, lower frequency it's the lower cutoff frequency, high frequency is high cutoff frequencies. So we go, as we know what are these, we come back. Y is your data, so you're going to click the variable, find the data, for example this, comma, and x will be the time, and then lower frequency, for example I would say 10 hertz, and the high frequency will be 200 hertz, something like that. Those two values are really depends on the situation that you try to calculate, and click done. Then there will be a new column, calculate, and if you try to plot it, you left click on the y-axis label and click the variables. The reason why this goes to really weird is because I choose the data is not really periodic, and it doesn't really have the 200 hertz signals here. So the Fourier trend the fieldings goes to infinite high. So whenever you see this kind of situations, that means you filter or the range, the frequency range you select is not match as your raw data. But here is an example. So how to use the filters. And then if I don't want it, I just click delete. Then it's gone. And the next function I want shows you is calculus. Inside the calculus, you can find the integral. Some things we need to know what's variable inside of needed, so we could use to help and find the function that list. Calculus derivative is here, and the integral also y and x. So come back, we know we need y, we also need x. Don't forget the comma in between, and time, and click done. And this is the integral, which kind of makes sense because the integral shows the area under the original curve. So if I plot this out, graph options, and you can plot multiple graph on one. So for example, here for better view, you can choose on the second y-axis, and then click done. Now you can see zeros here. Let me line those up so we can easily auto scale from 0. Auto scale from 0 and auto scale from 0. Okay, so see the area under the curve increased while the curve grows. And then yeah, always check if your plots really make sense before you carry out the next. Cool, that's the integral. And the next one I want to show you is goes to functions. Derivative will be the same way because they are requires the same input. The visual fielding will be the same. Integer, interpolate, rounding, statistic. So inside of statistic, you will have absolute, ceiling, floor, max, min, median, minimum, standard deviations, random integers, random real number, and they are pretty simple. So you can use the help to figure out how to use it. If it's hard to find, you can use type. Okay, the type doesn't really help, so you have to find out the alphabet by manually. So statistic, absolute. Just take one input. So the next I want to show you is not here. The next one shows you is Fourier transform that you might going to use in the EMG lab. So the Fourier transform is here. So you're going to use insert additional graph, Fourier transform graph. And to utilize this, you're going to right click on the graph and then find out the graph options. You're going to take the lead, find the peak frequencies, and then in this time we will try to use Fourier transform on force, and based on time, and then we're going to leave all as default. Again, like if you have any questions, what are those means and what are those functions, you can go to help. But here I'm just shows you there's a Fourier transform and basically how to use it. Now you can see after taking the Fourier transform, the force that were recorded is from 0 Hertz to 25 Hertz maximum. Cool. And then the peak frequency will be at 0.17 Hertz to 0.18. Okay. And the next I want to show you is peak integrals. So before peak integrals, I will clear out this for better review. Cool. Let's go back to the original force here. So we're going to find peak integration. So basically what is peak integration is it is quite similar to what integral integration does, but it gives you more information if you do use peak integrations. For example, here I can select one range and then click add. It's a peak 1, so you can see this red shaded area. So for example, if I label it as walking ground reaction force area 1, edit, and then if I choose another one a little bit higher here, edit, that will be ground reaction force area 2. Let's see. Okay, so now we can compare. So for example, the ground reaction force area 1, the area is about 51. So as you see here, there has two labeled area, 1 and 2, and then because you can drag this bracket to make it more accurate. on the area. Clearly that's bad. Okay, here. And then if I shorted this, cool. You can compare those two with the area values. The 531 is the area under curve 1, and then the 501.43, which is the area under 2. So you can see the area under 2 it's smaller than 1, so that means something. And that's the one of the difference between integrals and the peak integrations. So in peak integrations, you can find the individual area or the region that you would like to investigate, and then the integral, it will be the integrations under the whole curve. Cool.